Hello, this is Dave again, and I'm back, and we're going to do a quick dive into the memory report. These stats are collected and reported from the table analysis.instance memory and instance stats. Let's look at page life expectancy, also called PLE. The PLE is a measure of how long you can expect a page that has just been read from disk to hang around in memory. Okay? Now, SQL always looks for data pages that are in memory first before it goes to disk. If data page is not in memory and has to go to disk, that is a physical read or an I/O operation. If your PLE counter is low, that indicates that data pages in memory are regularly being overwritten with new ones. Now, physical I/O operations are expensive, meaning that the performance of your SQL instance can be adversely affected. So you want your PLE counter to be as high as possible. Okay, the higher your PLE is, the faster your load pattern will be, and things will be processed and kept in memory and just running smoother and faster. Now, what should this number be? There have been lots of blogs written on this and suggested numbers, and I've sort of thrown in a bonus report in the SSRS section that shows what we kind of use and go by on our system. Again, you have to do the research and find out what works best in your environment. So, your PLE is all out of whack. What do? Well, again, lots of research on the internet, but some of the things you might try is to drop unused indexes, merge duplicate indexes, watch out for very large queries, and evaluate the buffer pool. Index management is something to look at. Are you running, defragmentation scripts on a regular basis? Are your stats updating? Do you have auto statistics set to true? Things like that. Your temp DB, is there a space that needs to be allocated there? The buffer cache size, this is the size of 8 KB pages stored in memory. Whenever SQL needs a page of data, it has to go to disk to get it. We know that's an expensive I/O operation, and if the page is already located in memory, then it can be accessed quickly. We try to keep it at 95% or higher in our organization. That means we're effectively caching the data pages. This means fewer reads from the disk and fewer memory bottlenecks. Now, if this number drops way down, below 90%, definitely below 80%, that can be an early warning sign that something may be wrong. The OS memory utilization. SQL Server, we all know, is famous for holding and not releasing the RAM memory that it has used. This indicates the percentage of RAM that is being used and held by the operating system and SQL Server. Plan cache size. This is the total size in megabytes of the plan cache. Procedure cache hit ratio. This is the percentage of plans in cache that can be reused. A higher number is better. 90% plus is real good. The log cache. When data changes, it's written to the log cache, which resides in memory, and this log cache is flushed to disk whenever there's a commit or rollback of a transaction, checkpoint execution, and that can be an issued checkpoint or an automatic one, or the log cache is full. During peak time on an OLTP system, with small transaction sets, that's less than 40 rows added or changed on average, the number of log flushes should not exceed your SQL batches by more than 40%. Compilations per second. This calculates the number of SQL compilations per second, including statement level recompilations. A number greater than 100% can indicate a high workload. This may impact a server's performance. Compulations a second should be compared with the number of batch requests a second to get an indication of whether compilations may be hurting performance or not. To do this, just divide the number of batch requests by the number of compiles per second, and that creates your ratio. Ideally, you want to have 1 compile for every 10 batch requests, or better. Ad hoc queries, where plans and cache cannot be reused, are shown up here frequently. This also includes recompiles that are shown in our next report. Recompilations per second. When the execution plan is invalidated due to some significant event, SQL Server will recompile it. The recompilations per second counter measures the number of times a recompile event is triggered per second. Recompiles, like compiles, are expensive operations, so you want to minimize the number of recompiles. Ideally, you want to keep this counter at less than 10% of the number of compilations per second. Stored procedures with a planned cache that need recompiling may frequently show up here. We had a great example of a query that was taking a really long time to run, and we have this longest running query report, this one here, and the stored procedure was not showing up on the report. And that's because it was continually being recompiled. Even though it was one of our heaviest used ones, it didn't show up on this report, but we could see that the recompiles were extremely high. Once we rewrote this stored procedure and got it so that it wasn't recompiling all the time, it dropped off the recompiles, and then it did show up on the query wait stand report. Just remember that the longest running query report basically is just showing stored procedures where recompile isn't happening, and it's certainly not showing ad hoc queries or anything like that. These are things that are stored in that plan cache, and it's pulling stats on that. So it only gives you, a little window of things there.